And we're live. My name is Robert Ronan, and I'm a principal product manager here at Oracle, coming to you from Austin, Texas. For today's webcast, we have Bruno Andrade, founder of Shipa. If you've got any questions during today's webcast, please put those questions into the Q&A area, and we will address those at the end of the webcast. And with that, Bruno, it's all yours.
Thank you. Thanks for having me here today. It's great to have an opportunity to be participating and driving a webcast today with you folks, where we talk about a very great and important topic. Sounds good. So thanks everyone for having me here today, and for all of you folks who joined. Right, today we're going to be talking about application security and support, especially as we focus on the microservice side of the house and Kubernetes. And we're going to show you today by the end of the presentation on how you can tie up two solutions to drive both infrastructure automation as well as the application lifecycle management. And those two tools today are going to be Oracle and the Oracle OKE, or the Kubernetes Engine, and we're going to be using Shipa on the application side. Before we move into the presentation itself, just a little bit about me or about Bruno. If you do have kids, you probably understand what I have been going through over the last year or two with the Disney songs, where they keep singing "We Don't Talk About Bruno" everywhere where I go, school and my kids' friends and all of them, they keep talking about or singing that song to me. So I'll take the opportunity to talk a little bit about Bruno. So just frustrate Disney a little bit. But as mentioned, I'm one of the other founding members here at Shipa. I had an opportunity to do another startup before this one, also in the cloud native space, but more geared towards the infrastructure side of the house. And Shipa is very focused now on the application. I had an opportunity to work for companies such as IBM, Oracle itself, which was great. And I like to joke that I'm a failed musician. That was the original plan. Ended up going towards software engineering. And I'm not in my usual background, but usually would see guitars and a ton of stuff. But my kids, they keep telling me that the chance of a rock star life is pretty much gone now that I'm putting weight, losing hair. So can't go there anymore. As a couple of housekeeping items, this session is being recorded, and there is also Q&A available at the end of the session, or towards the end of the session. So if you do have questions, feel free to drop them, as mentioned, in the chat, and we're going to address them as we go. So getting into the topic, right? Where are we today from a user journey? If we look back into kind of the infrastructure related side of things towards the focusing on cloud native or microservices, Kubernetes, and so on, over the last couple of years, we've seen a shift and improvement on infrastructure, right? The first phase of cloud native, it involved a lot of effort and time spent on spinning up clusters, spinning up network and spinning up a bunch of stuff, and being able to manage that cluster infrastructure for your developers to be able to deploy their applications. As mentioned, that was time consuming. That involved a lot of cost and a lot of people to be able to maintain, and at scale, that became a pain, right? And over the last couple of years, we've seen solutions, pretty structured solutions like OKE itself, right? That take away a lot of the infrastructure components. So you can easily spin up clusters. I say, I can spin up a cluster with just a few clicks. So pretty much anyone, if I can do it, anyone here in this call today can do it. And it automates a lot of the components that you are seeing here, right, on this presentation, such as high availability, scaling, upgrades, and patching, which takes a ton out of the work from the DevOps or platform engineering team, and it helps you scale quickly. And now it shifts a lot of the, from a user journey perspective, a lot of the focus has been shifting towards the app management and app deployment. So you as a company or you as a team, you rely on OKE as a managed offering, and you're now onboarding developers, you're onboarding more applications, different teams, and so on, and you're scaling that infrastructure that you're putting together, right? So now these two layers are most of the focus and effort for your organization. And especially if you're sitting on the DevOps or platform engineering team, now you have to keep on scaling to make sure that there is developer experience, there is developer productivity maintained, and there is security. So that's where we are from a user journey perspective today, right? And if we address now, if we start thinking, okay, now my infrastructure is scalable, Oracle and OKE is helping me with that. Now I'm developing, my developers are coming on board, a ton of applications are being deployed, services, dependencies, and others. It's not unusual to see folks having difficulties on answering these three questions. At a first glance, they look pretty simple, right? What's running in your clusters, right? Can your team support it? And are your applications secure? If you're running just one cluster or a handful of clusters, or if you have a handful of developers or services deployed, that might be quite easy, right? But the reality is, if you're part of a medium to large team or medium to large enterprise, when you look at those three different questions or topics, it becomes a lot more trickier than it might look like. Because if you look at an infrastructure perspective, everything today is becoming fragmented, right? Teams across medium to large organizations might be using different infrastructure as code tools. Some teams might be using Terraform, while some other teams might be using Pulumi, Crossplane, or Ansible, for example. You might have GitHub Actions as a pipeline, while another team might have Jenkins, for example. You might have different cluster versions. You might have OKE 119 or 120, another cluster on 121, for example. And all of these variations in the underlying infrastructure, and even if you go deeper, for example, some clusters might have Istio, while some other clusters might have Nginx. So all of these differences in the infrastructure causes a ton of complexity for your developers to be able to properly manage their applications, because every change in the underlying infrastructure can represent a different way that your application gets deployed, or your application gets secured, or your application gets managed, right? And when it comes to the application support side, there's a lot of talks about the shift left type of mentality, which has tons of benefits. There are no doubts about it. But again, if focusing on the medium to large enterprise, if you're a developer, your development team, chances are that majority of your developers, they don't understand Kubernetes, or they don't understand Kubernetes well. And because they can't support their applications, the support falls into the DevOps, right? Or an SRE jumps in without much context. So it becomes hard, and it increases the effort on the DevOps team, hurts the SLAs and so on. And last but not least, application security, right? Especially if you have to comply with like SOC compliance, HIPAA, and others. Securing across different clusters, different pipelines, different applications, different requirements, it's tough. And if you look, this is just a simple kind of graphical representation, right? If you look from an SRE perspective, or an application owner, like such as a developer, he receives an alert, he or she receives an alert saying there's an alert, application X is down, right? For that application owner or application support person or SRE to get all the context that they need in order to support the application, there are a ton of information that they need, or history, in order to support that application. Who owns that application? Is that application compliant with the security requirement, right? What are the metadata involved? What are the dependencies of this application? If there is a problem with this application, are other applications also impacted by that problem? And without context and without information, and especially as you scale across so many clusters and pipelines and teams, answering those questions becomes difficult. And many teams, they have embarked on new initiatives, right? And to solve that challenge, you probably have heard terms like developer platform or other related, right? Developer portal or application portal, anything in that to solve that problem. And that is happening a lot across organizations, because even though there are only two blocks from my previous slide that you now have to tackle, Stripe did a recent survey that was quite interesting. They said that your developers today are only, in average, across organizations, 68% productive. And out of the time that they are not productive, one of the things that they spend most of the time is building custom technologies, because their developers cannot support and manage their own applications. And because And these initiatives are causing a lot of trouble. So when I talk to many organizations, some of the challenges that they're facing as they start driving these initiatives is that they underestimate the complexity, right? Especially the post-deployment management on top of such a fragmented infrastructure and integrating into the existing stack. It's not easy. And it's also, this should be treated as a product, not a set of scripts, right? And as you keep on evolving your applications, more developers come on board and so on, you have to treat it as a product, and you have to have a roadmap. You have to interview your users and so on. So there's a lot of work involved for that initiative to move. So when you look at it, okay, how do we make this work, right? How do we make sure people understand so they have enough context to support their applications and they have enough context to manage their applications, and we can easily support these applications moving forward? And that's where Shipa and OKE combined can help address some of these challenges, or these challenges that we covered. And how does that work, right? If assuming the same scenario before, you might have Terraform, or you might have Argo, Jenkins, or GitHub Actions, for example, as part of your CI/CD or automation platforms. And you're using these to spin up your clusters. You're spinning up an OKE cluster across different regions or different versions, regardless, right? You spin up a cluster and you have your applications deployed in that cluster. Great. You automated some of the Helm charts or some of the customized, for example, and you helped your developer get your applications deployed. Now, how do we bring that application lifecycle management or developer portal, for example, on top of the OKE cluster? Is by connecting Shipa to that OKE cluster, we have a capability, or we have a possibility to do what we call an application discovery or an app discovery, where by using labels that you define, and I'll show you in a couple of minutes how this is actually done from a technical perspective. But as soon as you connect that Shipa to your OKE cluster or multiple OKE clusters, Shipa will connect to your namespace and will start discovering the applications you have deployed. And in a matter of a couple of minutes, it will start surfacing all the application, all the metadata, and everything required for that application to run, and give enough context to any application owner to be able to manage that. The application discovery is dynamic. So as more applications are deployed, applications are changed, Shipa will reflect those changes on your OKE cluster on demand, regardless if you have running Istio or if you have Nginx, for example, or regardless of what pipeline you have deploying into that OKE cluster, Shipa will connect to it and will discover and show these applications on demand. From a second part, right, the security aspect, it works the same way. You have your different pipelines delivering to your different clusters. And as soon as Shipa starts discovering the applications, Shipa uses something called what we call a framework, or a framework policy, for example, which is primarily owned by the DevOps or platform engineering team in an organization. And that's how Shipa creates the connection with your underlying cluster. So when you create a framework, for example, you can create a framework called Dev, and you connect to your cluster and you say, hey, for my framework Dev, here are the set of policies that I want to make sure that applications comply with these policies. For production, for example, you can create one or multiple framework policies and connect to these clusters. And as the applications are discovered, they will then start showing how they comply or how they violate the policies that you created across a broad set of domains. And you're going to see that you can easily fine-tune these policies without having to write any complex rule or any cluster-specific rule. So now you can start onboarding more folks from the DevSecOps or security team or management team, and they can have clear visibility over that. And especially if you are in high regulated industries such as financial services or healthcare, for example, this becomes extremely important when times are for audit, when you have times for audit and so on and so forth. So ultimately, last slide, so I promise not to put it to sleep any longer. What you are doing, right? When you put the two solutions together, Shipa and OKE, your teams can easily find who and what happened to your applications over time. You can drastically reduce the time to identify the issues with your application and support this application. You can facilitate security teams address compliance requirements, again, PCI, SOC, HIPAA, and more, on top of your microservices strategy. So you can address that requirement from a security perspective, and you can identify and resolve security threats in a scalable model, again, because you're not developing anything from a cluster perspective or a specific infrastructure component. So now I'll go to the demo. All right, so I think you folks can still see my screen, but now I believe you all see a dashboard. If that's not correct, please let me know. But Shipa, what you're seeing here today is an instance of Shipa. I'm going to be using Shipa Cloud, which you can create a free account. It's a SaaS service. It's under apps.shipa.cloud. Again, apps.shipa.cloud, SaaS service, you can create an account, pretty easy. From an infrastructure perspective, I have two clusters. I have my two OKE clusters. Both are in the same zone just to facilitate things. And what I'm going to be addressing is if I go on cluster 1, for example, which I'm connected using my terminal, I can see that I have a name. I already have my cluster running. I have a Magento prod namespace called. And if I get my pods from there, you will see a set of pods running, right? Let me just make this a little bit bigger. If it's too small, let me know. All right, so from an infrastructure perspective, I have an OKE cluster, where I have a couple of OKE clusters. I have a Magento prod namespace, and I have a set of services or applications deployed in that cluster, right? I deploy Magento, but assume this can be any in-house developed application or anything that you're deploying for what matters across multiple namespaces and multiple clusters. Great. So when you join, now the goal is I have my OKE. Now I need to give my developers, SREs, and security teams the visibility they need in order to manage and secure and support these applications. And that's where Shipa will come in together with OKE. If you create your account on apps.shipa.cloud and you don't have any data, instead of the dashboard that you see here, you're actually going to see a self-guided tour that's going to guide you all the way to discovering your applications and have things managed or your applications managed, right? Because this is my account, I already have a set of things deployed in here. You get some of the data that shows up as your applications are discovered. The first step that you would go as soon as you start signing up is creating what we call a policy framework. Remember, we mentioned policy framework are usually a set of rules or policies that you define and you connect to your underlying cluster. And those policies will be used to discover the applications and will be used also to see how these applications comply or violate with the set of policies you define, and start showing the application metadata and have that developer portal on top of your OKE instance without changing any of your pipelines or without changing any of your OKE clusters, for example. So if I come in here and I click on create, I have three options, right? Option 1 is just the reasonable defaults. Option 2 is to help me discover applications. And option 3 is to define very detailed policies. Just to get started, let's discover an existing application because I already have my Magento application deployed in my OKE cluster, and I want to discover and see what it looks like. If I click on next, I have to enter a name for this policy framework. I can just enter Magento prod, for example. From a plan perspective, I should select what resource plan, which you can create on Shipa here under the plans tab on your menu, which is the limits of CPU and memory, for example. You should say every application that I discovered in my Magento prod namespace should comply with these limits, right, that I created for my plan prod or dev or whatever plans you create. The Magento name, the Kubernetes namespace to which Shipa will connect to discover my Magento app. So in this case is Magento prod, as we've seen before. And the second one is a team, or which teams should have access to this application once it's discovered, right? You can use Shipa to create multiple teams, connect to your AD, for example, or others, and start addressing multiple teams and roles and responsibilities directly here. But I'll select the Shipa team, which is pre-created. You should have that in any new account. When you click on next, what Shipa is going to ask you to enter is a label. Labels are probably already defined in a Helm chart that you use to deploy your application, or in your customize, for example, or your deployment set, or you can enter any labels that you have in those deployment scripts that you have. And Shipa will use those labels in order to discover applications and effectively show them here. Finding them, it's easy. So if we go back here, I can, for example, use kubectl, describe pod. And if I describe my pod Magento app, my pod Magento, sorry, in this namespace, you will see that I have a few here called labels, right? And I have a set of labels here that I could use any. I know, for example, that this app Kubernetes IO name is a common label that I have across all the services. So I could use this one. So if I go back here and I say app Kubernetes name, and optionally I'll enter a suffix, I'll say Magento OKE, for example. So every time a new application is discovered in that namespace, or a new service is discovered, I want Shipa to add the suffix Magento OKE. All right, we click on create. What we've done here, we've created a framework, right? But this framework is not yet connected to my underlying cluster. I just put a framework name, a resource plan that application should comply with, what's the name of my namespace, and which label I should use. Perfect. So now if we come here into clusters and I click on create, now I have an option to connect that framework, or that policy framework that we just created, to my underlying cluster, or my underlying OKE in this case. You can connect one or multiple frameworks to the same cluster. So if you have namespace development, staging, production, or project one, project X, for example, you can create multiple frameworks, and you can connect all these frameworks to the same cluster, and they're going to connect to the different namespaces that you have assigned them to. The Shipa is going to ask me here for my Kubernetes control plane, which it shows here the command as well for you to get this. So if I just run, it's going to give me my Kubernetes control plane. And I can enter a name for my cluster if I want to. When I click on generate command, Shipa will give me what we call a magic link, right? I can run this magic link directly from my terminal as long as I'm connected to my cluster. And it will start connecting, deploying the Shipa agent, creating the namespace, deploying the agent in your cluster, and we'll start linking your data back from your cluster to the Shipa control plane. As you can see here, it creates the namespace, creates the role binding access, service accounts, and so on that Shipa requires to connect to your cluster. If we click on done, the connection itself takes about 1 to 2 minutes, and you can see here that the cluster create is running. You can use the same approach regardless if you are connecting to an OKE 120 or 121, for example, or different versions. And as you have seen, when defining the policies, we haven't defined anything from a cluster specific or ingress specific or anything. So those are defined in a general way, and you can connect to any cluster, which is great because it then separates the application from the underlying infrastructure. So the DevOps team can keep on updating cluster versions. You can keep on spinning up new clusters or test new ingress controllers or what have you. And the way you scale these applications or you connect Shipa to your applications are pretty much, or define policies are pretty much the same. While Shipa is connecting here, I have one cluster pre-connected here. You can see the second one is coming, it's connecting right now, and you can see the status of each of the Shipa components that are deployed in your cluster. I have connected previously my second cluster, my first cluster, and you can see all components are running here. Great. So from a DevOps perspective or platform team, you sign up for Shipa, you created a policy framework, and you connected to one or multiple clusters. And you've seen that these clusters are in, or one of your clusters are already in a connected way. You can add your teams directly from here. Shipa allows you to connect to an external authentication directory you might have. Shipa supports SAML, for example. So you can pull in your users from your Active Directory. And directly from here, you can create teams to address requirements such as Project 1, Team 1, or Team 2, for example. You have some pre-canned roles directly here that you can use, such as DevOps or operator or developer or admin. That saves a ton of work, especially if you're doing kind of RBAC in Kubernetes. You know that at scale, that can become quite painful to manage the right permissions for your users. And directly from here, you can invite your users directly and assign them to a team and a role, and they'll get an email, they'll sign up here, and it hides the complexity of the underlying Kubernetes to them. So they access pretty much what you give them access to. If they are a developer, you're going to see that they're going to have access to, yes, they'll see the definitions of the framework. They'll see the definitions of the cluster, which now my cluster shows as running. If we go to events, it shows as successful, and they'll have access to their applications, right? If I go into applications now, in a few seconds, what's going to happen is now that Shipa is connected to your underlying cluster, you see that your applications will start getting or will begin to be discovered by Shipa, and these applications or my Magento application will create events directly here showing app discovery and policy violations. And in a few minutes or in a few seconds, these applications will show. But the data before these applications show, if we go into an application that I have deployed in the previous cluster, you can see directly here, let's say I'm an SRE or I'm an application owner or developer, for example. Directly here, I can see any resource limits that my application has. I can see any container images that my applications are using, so I can quickly identify what version of my image that this application is using. I can see any environment variables that my application needs to run. I can see things such as the CNAME where my applications are exposed, so I can quickly identify how to give access to external users if I want to. If there are any auto-scale rules or config maps, for example, you can see them directly here as well. So now your users or your developers, they have a complete metadata information of your application that they need to understand who owns the application, what are these application dependencies, and how are they running or exposed, right? As your applications start receiving access, you will see information around transactions and how these applications are performing, which can be connected to any external monitoring tools such as Datadog, New Relic, Prometheus, or others. You'll be able to see container information for that application in the status of that container. So you can quickly identify if you have a problem in a specific container, for example, and the log associated to that. Another great thing is that you can also get information around lifecycle. And this is extremely useful for folks such as the SREs or security or audit for folks, for example, because every time you connect Shipa to a cluster and it starts discovering the applications, you see an app create, for example, event. And from there, every time there is a new deployment, you're going to see the log associated with that activity. Every time your application scales up or scales down, you're going to see that activity also logged in here. If your application restarts or your application has problems, you will see all the history on timeline of your application. So now when you jump in to troubleshoot an application or to audit an application, for example, you have complete information about who did what happened, the log associated, and when that happened, for example. So now you have metadata in history context to be able to support that application effectively, right? For your developers, they have log information directly here. So you can remove a lot of the kubectl need from your developer. They have access to all the log, all the metadata, and all the information directly here. They also have integrations directly here. So if you want to, or your developers want to connect this to incident management tools, such as Jira, ServiceNow, Slack, Teams, or others, for example, they can create events. So every time there's an application shell, someone shells into your application, or application restarts, or there's a problem with the application, this gets an alert created and sent to Slack, for example. Great. So your application owners, developers, and others, they get all the metadata information they need, right? But one of the problems that was highlighted in that Stripe research was that a lot of the developers, they have pretty good understanding about their code, and they have pretty good understanding about their container image. But past that, they very few of them, they have understanding of the underlying infrastructure that their application needs to run. And that's what we address here with the dependency map, right? What this dependency map is showing is you have here your simple application, but here are your images, for example, that your simple application needs to run, the details such as the Docker image, the image digest and others, and the status, who created and updated that image, where this is exported, and so on and so forth, and the log associated with that. You can find pod information and so on. And so now, okay, great. This is, I now understand what my container is. And now I can understand what all the objects that I need to run my application are, the status of these objects, and the log associated. And this map is pretty much dynamic in a way that when there is a problem with a pod, a problem with an image, or a service account, for example, these will turn red, and your developer or SRE, for example, they will be able to quickly spot the error or the message. It's a problem with a service account. It's a problem with my image. And here's the log associated. Maybe your image was not found, or credential to pull your image from a private registry. Now they can start really supporting their applications on an ongoing basis, right? And here on the other side, we have the network side. Here, basically, my application is saying that I have a rule saying I can ingress data to internet, basically, and egress data to internet. So now you can identify which services my simple application connects to, and remembering that this is just connecting to the OKE cluster, right? I haven't changed anything on my OKE. I can keep on using Istio or whatever ingress controller I have, and all these informations that I need are going to be shown directly here. If I go back into my applications dashboard, I can now see my Magento app. Yay! So discover my Magento app that we just connected, right? We went through the process of creating a framework, connecting to a cluster, and discovering the apps. If we go, you can see that you have three services, Elasticsearch, the Magento itself, and MariaDB. If we go into Elasticsearch, for example, you're going to see all the information that we've seen before, but you're going to get more detail because this one is a larger application. So more container images, different environment variables, for example, that Elasticsearch needs to run, any information about config maps, for example, for each of the pods you have, and the endpoints where they are exposed. You're going to see the same metadata information, but this is way more complex, right? So now think about someone who has to support a much more complex application. They can get all this detail directly here. And just like the previous simple application, you can get all the detail here for your volumes, logs, and everything else, right? And here you can also understand a very busy network map. And the reason is because there are no network policies attached to this application, right? So if you're running a production cluster with production applications, you can quickly spot that basically your applications can ingress and egress data from and to anywhere, which is far from ideal, right? So now you can quickly understand. I hope that makes sense. If it doesn't, feel free to post it in the chat and let me know. A second part that we've seen here is the violations, right? And the violations are based on the policies that we define, right? The framework policies. We just defined the policy for our resource plan, the limit on our resource plan, as far as I remember. So if we click here, I'm going to find policy violations or compliance across a different set of domains, such as container registry, where applications are exposed, resource limits, and so on. And right out of that, without having to kind of dig into Kubernetes and to try and create reports and show my security team how this is done, I can see that my Elasticsearch app actually violates one of the resource limits because these are the limits that I define in my plan, but the application is actually using a lot more. So if you're concerned about cluster performance, you can quickly identify that here. And the second one, you can see pod security aspect, right? You can see that this has no pod security defined at the cluster level, which exposes a lot of security threats to your cluster. Everything checks out, but for example, let's say tomorrow there is a new requirement. Let's say this turns into a production policy. So if I come in here into my Magento prod and I update that, you're going to see that Shipa gives me access to a ton of information directly. So if I come and say, you know what, applications deployed in my Magento prod namespace should only come from Docker IO Shipa software, as an example. Because this is a production app, for example, you can say applications should not be exposed on any endpoint other than shipa.app1.shipa.io and others. But I want to come in here and I want to say applications should be denial for ingress and denial for egress, for example. And I want to enable security scans, and the only vulnerability that I want to accept in my cluster is log4j, because I like to live in the edge. So anything else shouldn't be treated as an exception. And even auto scale things. So if you want to come here and say, because this is a production app, every application should have a minimum of 5 replicas and maximum of 15 replicas, and they should scale every time it gets to 85%. Once I update this policy, Shipa will apply this policy and see how your applications comply or violate with the new set, right? So again, if you have OKE 119 and tomorrow it turns into a 121, you don't have to make changes. If you update your ingress controller, if you update monitoring or anything, your policies are defined in an application-centric way or application-focused way rather than underlying infrastructure. So your security team or DevSecOps or platform team or whoever takes care of the security aspect can keep on fine-tuning your applications and see how these applications perform against these new policies or updated policies. If we go back into applications again, you can see that these changed, right? You can see now there are 5 violations. If I come in here into my Elasticsearch, I can quickly see that, well, you said the only allowed host is Docker IO Shipa software, but Elasticsearch is actually pulling the container images from these places, right? Same thing for our autoscale. You can see that it's not complying with this part. Or my network policy, I'm saying it's the denial, but it's actually my pods are set as allow all. So you can quickly spot and fix security problems, right? In a way that it's scalable and again, not complex to handle based on the underlying infrastructure. Last but not least is the insights. So if you have too many clusters and if you have too many applications, too many teams, this is where centralized information comes together. So if you're part of a platform team, security team, or management team, for example, you can see policy violations in general, application performance in general, deployment information. You can see which applications are actually performing well or performing poorly. You can see which teams are actually addressing security requirements or constraints that you have, which clusters are being mostly used, response time for your applications. And as the previous report, you can see detailed policy violation for all your applications or all your services. So here you have a centralized platform or centralized way for your DevOps, platform engineering teams, or management teams, SRE security, and others, to audit the applications across all clusters, all teams, and more. I hope that was helpful. And it showed you how you can combine Shipa and OKE to address and remove the infrastructure complexity from the DevOps or platform team by using OKE and all the automation provided. And by layering over Shipa on top of OKE, you get a complete developer platform for application management and security. I hope that was helpful. Does that make sense? Any questions that we can help?
Yeah, we can go through the Q&A section. I do have a couple questions that did come in over the course of the last 20 or 30 minutes. So the first question, does Shipa support different Kubernetes versions when connecting to clusters?
It does. So you can use OKE 120, OKE 121, or 122. Shipa can connect the frameworks to the different versions you have, or even if you have a cluster connected to a Shipa framework on 121, for example, and you upgrade that one cluster to 122, Shipa will keep on connected to that. So you detach basically application from infrastructure. You can use whatever infrastructure version you want and still connect Shipa to it and get all the application benefits.
Perfect. Second question. Is Shipa only a SaaS-based offering, or can you install it on-prem? For instance, if you were to have a, air-gapped environment or something that wasn't publicly available.
Yeah, that's a good point. So Shipa is provided by default as a SaaS service under apps.shipa.cloud, but Shipa does have a self-hosted version. In the documentation itself, under installing self-managed Shipa, you can get detailed information around how to add Shipa's Helm chart to your infrastructure and install. So you can run Shipa control plane, everything that we went through, directly in your OKE cluster. So you can address gap environment, or if you're high regulated industry such as banks, for example, that everything needs to run within your VPC, you can do it that way as well.
Great. Here's another one. Is a normal policy framework the same for dev, test, and prod environments?
Very good question. So not really. Unless you are deploying all your applications into the same namespace, then it will be. But majority of the cases that we see out there, folks, they break environments down by different namespaces or by different clusters even. So you can come in here and you can create a new framework. For example, I can say staging. I can select the resource plan that I want, and I can say connect to my OKE cluster. And Shipa will connect to a staging namespace in that cluster. So you can create different policy frameworks with different set of rules for each environment you have and connect it to different namespaces or different clusters. That's how we see users using it today.
Perfect. Here's another one from the same individual. How easy is it to edit an existing policy framework for prod to suite, test, and dev respectively?
Yeah, it's pretty easy. I mean, I can do it, then I'm sure you can do it. So if you come here into frameworks, for example, this framework is connected to the cluster that we created. If we come in here and we click on update, for example, you can update these policies. Oh, that's a good question. So you can update these policies directly here in the dashboard, and you can see it's pretty kind of self-explanatory. You don't need any Kubernetes experience to do that. But you can also do that or interface with Shipa. Everything I'm doing here, I'm using the dashboard. But a lot of the teams that we see using Shipa today, they use infrastructure as code to interface with Shipa. So Shipa has providers for Terraform, for Pulumi, Crossplane, Ansible, GitHub Actions, and so many others. So you can actually create the policies, connect to a cluster, discover the applications, everything automated from your pipeline or your infrastructure as code. And actually, if I come in here and if I show you Pulumi as an example, if I come into kind of the framework management section with Pulumi, you can see I'm defining, for example, the same thing we defined in the dashboard or at the same level, but using infrastructure as code. So here is security, and then if I want to enable or disable, and what components I want to ignore, if any, auto scale. And again, you're defining this in a very kind of quote unquote English way. You're seeing that you're not defining anything for Istio, for example, domain policy. If you have to define these across multiple cluster, different Istio versions or ingress, it can become a nightmare. So you can do very easily from the dashboard, or if you want to do it in a on a way that you can trigger it from your pipeline, so you can keep on replicating that. You can do that from any infrastructure as code tool that you want as well for pipeline.
Awesome. We've got actually 2 more questions.
Yeah.
Keep them coming, guys. We've got some time left. We got to the top of the hour. Are policies dynamic so that they will reflect a new configuration if they are changed?
They will. So every time you change a policy here or a framework, for example, it will reflect on the violations that you have for your applications. And you can choose if you want to just highlight the violations. For example, when we came in here and we added minimum set of replicas and for 5 and the maximum amount of replicas. And when we come back to applications and we see here, for example, now there is 6. So I can see even that security scanning is actually Shipa ran a security scan and it shows here. So everything is dynamic. If you add a new security scanning exception, Shipa will treat that right away and it will show a dynamic report, which is very useful, especially around security scanning, because a lot of folks, they are very good at run security scanning in their container registries, for example. But many times the version that you already have running in your cluster is not the same version that you have secured in your container registry. So here it's easy for you to run that comparison. So every time you update your frameworks, it will show the violations in the dynamic.
Perfect. And last question. Can I use Shipa to assign different user roles and permissions?
You can. So we have our backend Kubernetes is quite complex, right? Probably a ton of the folks here in this call today, they understand that. So what we did is we allow you to connect Shipa to your existing AD or SAML-based directory, for example, to pool your users. And we created pre-canned roles with roles and responsibilities for operators, DevOps, and developers. But you can expand those roles or create new roles if you want to assign that to users and directly here invite these users. Everything can, again, the same way be managed directly from the dashboard, or it can be managed directly from your infrastructure as code or pipeline. So you can quickly replicate that in an ongoing basis as well. But yes, you can definitely do that here.
So last question, if someone wanted to get started with Shipa today, tomorrow, how do they get going?
For sure. The best way for you to get started without putting any work on even installing anything is by signing up for the Shipa Cloud. So you can do that. I'll send that in the chat as well under apps.shipa.cloud. You can sign up, doesn't involve any cost, and you can connect to your cluster and get the same results that we got it today here. Connect to your OKE cluster and discover applications. That's by far the best way and how we see users getting started. And later, if they have to move to a self-hosted version because of whatever limitations they have, they can do that by visiting the documentation and following the instructions on installing the self-managed Shipa.
Perfect. Awesome. Thank you so much. Any closing remarks or anything you want to tell the folks that are in the webinar today?
I appreciate everyone's time today. And if now application, as mentioned, becomes the next frontier for folks to solve the problem. And I'm keen to seeing folks, how folks are tackling that problem. I would love to see some of you using Shipa or all of you using Shipa and OKE. And you can also find me on LinkedIn or on Twitter. And feel free to contact me with any questions, thoughts, or opinions. I'm always open and love to learn from everyone.
Thank you so much, Bruno.
Thank
and
you
with
all.
that, we will conclude the webinar. Thank you, everyone.